All right, so now I'm going to move on. If you are not able to join the Google Classroom, we will also help you join after today's lecture. But the link is in the chat, so go ahead and click that link if you need that. So let's get started.
Hey, sorry to bother.
Yeah.
This is for the UMTYMP Prep class, right?
Yes, it is.
Okay, thanks.
Yeah. So for everyone that's already joined the Google Classroom, if you go over and head over to classwork, you should be able to see a pre-algebra handout, which is a downloadable PDF. You guys can go ahead and download that file. That's what we're going to be going over today, every single topic in that file. So I'll give you guys some time to download that. So now I hope you guys can all see my screen now.
No one is answering my questions.
So I'm going to go over the handout now. So let's get started on learning these concepts. So the first thing that we need to know is PEMDAS. So PEMDAS, which is PEMDAS, this stands for parentheses, exponentiation, multiplication, division, addition, and subtraction. So this is the order in which you should do your operations. So the the things that come first are more important, and you should perform those operations first. So for example, let's say I have this expression like 4 times 3 plus 2. So you guys can answer this in the chat, but what is 4 times 3 plus 2? That's great. I see a lot of 14s in the chat, and that is the correct answer. Why? Because when we want to evaluate this, we first do multiplication, which would be the 4 times 3, and then we do the addition, right? Because multiplication, which is m, comes before a, which is addition. So if we do that, it becomes 12 plus 2, and this is 14. All right, how about another example? What about 4 divided by 3 times 2 squared, and then in parentheses plus 1? What about this? Try using PEMDAS. I'll write it again up here. So remember, P is parentheses, E is exponentiation, M is multiplication, D is division, A is addition, and S is subtraction. And again, you guys can post your answers in the chat. Okay, so this one's a little trickier, and that's because it has parentheses. So when we have parentheses, we first evaluate what's in the parentheses. So I see here that I'm gonna enclose this in a box, but these are the things that are in the parentheses, right? The 2 squared plus 1 is in the parentheses. So I have to evaluate that first. So now my goal is to evaluate 2 squared plus 1. So I'll write goal right here. So my goal is to evaluate 2 squared plus 1. And this itself has its own PEMDAS order of operations as well. So here in 2 squared plus 1, I have an exponentiation and I have an addition. So which one comes first? I know that exponentiation comes first according to PEMDAS, right? E comes before A. So I'm going to evaluate the 2 squared first, and that becomes 4. And then I'm going to evaluate the plus 1. So this becomes 5. Then if I go back here, so I know 2 squared plus 1 becomes 5. So boom, I'll have 4 over 3 times 5. And then this is easy to evaluate. It becomes 20 over 3. So,
Aaron, I'm going to interrupt you.
yep.
I just had a request in the chat to slow down a little bit.
Yeah, of course. So you can always refer back to the handout if you ever forget what PEMDAS or anything stands for. But I'll do one more example a little bit slower. So make sure you guys, if you guys are not already familiar with PEMDAS, make sure you really get PEMDAS down because that is the basis for all orders of operation. And on the entrance exam, they're really going to be testing if you know your order of operations. And mathematical expressions are always going to be expressed using PEMDAS or assuming that you guys understand PEMDAS. All right. So let's go over one more example. I'll go a little slower this time. So let's say we have an expression like 2 squared times 3, and I'm going to put this in parentheses. I'm going to go ahead and add 1, and then I'm going to multiply by 3. So let's go over this now. Oh, and let's also throw on a divide by 6. So how would I tackle this first? What is the first order of operation that I should do? You guys can put your ideas in the chat. Which operation should I perform first in this expression? Remember, we have PEMDAS, PEMDAS. Yeah. So if you put parentheses in the chat, you are correct. Ding, ding, ding. Congratulations. So according to PEMDAS, we do parentheses first, which means that we have to evaluate whatever's within the parentheses first. So this means I'm going to have to evaluate 2 squared times 3, right? So how do I evaluate 2 squared plus times 3? So right now my goal is to evaluate 2 squared plus 3 or times 3. So how do I evaluate 2 squared plus 3? Which operation will go first for this one? Okay, so to evaluate 2 squared plus 3, I would do exponentiation first, right? Because according to PEMDAS, E comes before M. So I will do exponentiation before multiplication. So 2 squared is 4. And that means all I have to do now is figure out what 4 times 3 is, and I know that is 12. So I have now completed my goal of evaluating what's within the parentheses, and it's 12. So I'm going to go ahead and replace the thing in the parentheses with a 12. And I can get rid of the parentheses now. So now I have to evaluate this expression. Now, how would I evaluate this expression? What is the next step? What is the first thing that I should do? According to PEMDAS, what is the most important thing to do in this expression? You guys can put your answers in the chat. Yeah, I see a lot of multiplications, and that is correct. So the first thing I would do is multiplication because comes before addition and division. So when I do multiplication, I will do 1 times 3, and that is 3. So I'm going to go ahead and replace this with a 3. So now I have this expression left. I have 12 plus 3 divided by 6. Now, which operation comes first in 12 plus 3 divided by 6? Yes, it would be the division, which is the D. That is very correct. So 3 divided by 6 is 1 over 2. So I'm going to go ahead and erase that and put a 1 over 2 here. So now I have the final thing to evaluate, which is very easy. There's only one operation, and that is addition. So when I do 12 plus 1 over 2, I can either write that as here, I'll write it again. So 12 plus 1 over 2 can either be a mixed fraction, like 12 and then 1 over 2, not 1 over 12, 1 over 2. Or I can write it as an improper fraction, which would be 25 over 2, right? So there we go. So that is our final expression. All right. So PEMDAS, PEMDAS, PEMDAS. Make sure you guys understand PEMDAS. So now let's go to our next concept, which is exponentiation. So I don't know if you guys have learned this yet in school, right? I think many of you guys here are fourth graders or fifth graders. Maybe some of you guys are sixth graders. But regardless of whether you know this or not, these are really important to know. So we will teach you them right now. So what are the exponent formulas? So let's say exponent formulas. These are just general rules with exponents. So we all know what an exponent is, right? If we have some number, let's say a raised to the power of b, that is just a times a times a times b amount of times, right? So I'm sure we're all familiar with this concept. So for example, here, I won't erase this. So for example, if I have 2 to the 3, that would be 2 times 2 times 2, right? 2 multiplied by itself 3 times, which would be 8. All right. So now what if I have like two exponents multiplied together? What happens then? Let's say I have 2 to the 2 times 2 to the 3. Well, if I use PEMDAS, right? And I evaluate the exponents first. So let's evaluate this exponent first. 2 to the 2 is 4. And then I'll have times 2 to the 3. And then I'll have to evaluate this exponent next, which is 8. And then I'll have 4 times 8, and that's 32. I could do that. But there's also a nice rule. So maybe you have already noticed that 32 is 2 to the 5th. So what do you guys notice here? Do you guys have any insightful comments about what you notice here? Here, I'll give you guys a hint. So I'm going to circle something. Maybe you can notice it. Yeah, when you multiply two exponents together that have the same base, and our base here is 2, and the base is just like the number on the bottom. To get the answer, you can just add their exponents, right? 2 plus 3 is 5. So this is our first rule. A to the n plus, no, sorry, a to the n times a to the m equals a to the n plus m, right? This is the very first rule of exponents, and it's a very nice rule. So now let's go over a second example. Let's say we have 2, right? Let's say we have 2 squared squared. What is this? Well, if I evaluate this using PEMDAS, I would have to first do the thing in the parentheses, which is 2 squared, and that's 4. And then I will do 4 squared, which is 16. And I'm just going to tell you guys this, but 16 is 2 to the 4. So what do you guys notice? Oh, this is kind of a bad example. All right, let's change this top one to a 3. Then this will be 4 to the 3rd power, and this is 64. And then 64 is 2 to the 6. So what do you guys notice now? I have a 2, a 3, and a 6. And if you say that they multiply together, that's correct. So here is our next rule. A to the n to the m equals a to the n times m. So this is another handy rule to know. All right. Now let's go over to the third one. So coming from this rule, we have another rule, which is a to the n divided by a to the m equals a to the n minus m. This rule right here comes from the very first rule, right? And that's because when we are dividing by something, we can just write that as the minus exponent. So, for example, 1 over a equals a to the negative 1. 1 over a squared equals a to the negative 2. So if we have a to the n divided by a to the m, that's just a to the n times a to the negative m. And using the first rule, we know that it is this. So that's another rule to know. And let's go over one more rule, which comes from this one. And that's if we have the mth root of a to the n, this is just a to the n times 1 over m, which is a to the n over m. And that's because when we're using this notation here, like this kind of square root looking thing with the small m right here, that's called radical notation. And basically it just means that if I have something like this, it'll just be like that. So for example, the square root is a to the 1/2 power. And for the square root, we omit the 2 because we're lazy and we like that. But if we have the cube root, for example, it would be written like this. So this is radical notation, this is exponential notation. All right. I have one more exponent rule, and it is, let's say, so all of these rules that we've just gone over, all of these exponent formulas, these are assuming that the base is the same. The base is this bottom number. So we're assuming that the base is the same. But what if the top is the same? Well, there's one handy rule for this. So let's say we have two numbers, a and b. So if we have a to the n times b to the n, this equals ab to the n. And that's because exponents are distributive over multiplication. So I'm sure you guys have maybe learned the distributive property in school. So, right, if you have a multiplication, so let's say we have 4 times 1 plus 3, that is 4 times 1 plus 4 times 3, right? So the distributive property here, and that also works kind of for exponents. And that is if we have ab to the n, we can distribute the exponent kind of, and it's a to the n times b to the n. So this is our last exponent property. All right. Now, oh, I lied. I lied, actually. There's one more very neat special exponent property. It's just a very simple one. It's anything to the power of 0 is 1. Maybe you guys haven't really learned this, but anything to the power of 0 is 1. So that are the exponent properties. All right. So I'm going to give you guys some time to process this. Maybe write it down if you haven't started that already.
If any of this is confusing, by the way, feel free to ask a question.
Yeah, feel free to either unmute and ask me or ask it in the chat to either Kevin, Aditya, or Eric. All right. Now I'm going to go over logarithms. Logarithms are pretty challenging. Maybe some of you guys have learned this in school, but I really doubt it because logarithms are pretty challenging. So I'm going to first define a logarithm for you guys, all right? So I'm going to first, actually, I'm going to give you guys a hypothetical question, okay? So we learned all of these exponent things, and now let's say your friend Charlie has a puzzle for you, has an exponent puzzle for you. He says, suppose I have a 2, and it's to the x power. And let's say this equals 8. And Charlie says, I want you to find what x is. So how would you find what x is here? Yes, x is 3. That's because 2 to the 3 is 8. So now how can we rewrite this? If we rewrite this somehow, we will get something known as logarithmic notation. So let me show you guys how. So basically what we did here is we're solving for x, right? But we could also say that x equals log base 2 of 8. So x equals log base 2 of 8. And this basically means that you're trying to find some value of x that when 2 is raised to x, it equals 8. So this is just a way to write Charlie's game in one neat little small notation. All right, so now I'm going to give you guys a practice question. So let's say y is log base 3 of 27. What is y? And remember, this notation just means that I want you to find a y that when 3 is raised to the y power, we get 27. Yeah, so I'm getting a lot of 3s in the chat, and that is correct. Y equals 3 because when 3 is raised to the third power, we get 27, right? 3 to the 3 is 3 times 3 times 3, which equals 9 times 3, which equals 27. So there we go. So that means log base 3 of 27. So that's how you say this little thing right here. Log base 3 of 27 is 3. Okay. Let's do one more question. So I want you guys to type in the chat. I want you to rewrite this expression into a logarithm. So let's say I have 6 to the a equals 36. I want you guys to rewrite a into a log expression. You don't have to find the value of a, but I want you to rewrite a using logarithmic notation. You can just write this down on a piece of paper. The bases here aren't that easy to type. You can give it your best bet though, or your best try if you want to. All right. So this is very tricky. Logarithms are indeed very tricky. So this is why we need to practice this notation a lot. But the answer here is we can rewrite this as log base 6 of 36. So if we remember, if we go back to Charlie's game, if we have 2 to the something equals 8 and we want to find what that something is, it becomes log base 2 of 8. And we say log base 2 because if you notice, the vocabulary is the same, right? 2 is the base of the exponent, and it's also the base of the log. So that's the way that you can remember it. And then the number that we're trying to see what it equals is always going to be to the side as the bigger number. So if we go back to our example problem here, 6 is our base for the exponent, right? So it's also our base for the logarithm. And then we'll just throw the 36 right here. So a equals log base 6 of 36, and that's 2. All right. Now I hope you guys have this notation down. I'll write some practice problems here on the side for you guys to still solve because this is a very tricky thing. So I want all of you guys to solve these 3 practice problems. I'll give you guys a few minutes. So I want you to find x for all of these practice problems. So you can both rewrite it into a logarithmic expression, and you guys can also evaluate it to practice solving logarithmic expressions. All right, let's go over the first problem. So 2 to the what power equals 16? Well, it would be 4, and we can also rewrite this in a logarithmic expression, that being log base 2 of 16. All right, for the second one, x is 2, or x is 3, sorry. X is 3 because 4 to the 3 is 64, and we can rewrite this as log base 4 of 64. And for 3, x is 2. Because here we want to solve Charlie's game, right? 7 to the x equals 49. And we know that x would be 2 because 7 squared is 49. All right. So you guys can take a screenshot of this if you weren't able to figure it out. But don't worry, this stuff is pretty confusing. All right. So now I'm going to go over logarithmic properties. So we went over the exponent properties. Now we're going to go over the logarithmic ones. So these ones are closely related to exponents, right? Because exponentiation and logarithms are kind of like opposites, and they are opposites, in fact. You'll get to learn that more in algebra, but they are inverse functions. So, but let's not get too ahead of ourselves. So let's go over some basic logarithmic properties. So I'll write the very first one. So let's first, if you guys are still a little shaky on this, I'll write out the definition of the logarithm, which was this, right? So that's how the logarithm works. That's how we use the logarithmic notation. Okay, so here is the first property. So if we have, let's say, log base c of a times b, that is log base c of a plus log base c of b. So this is the very first property. All right, so this is a pretty hard one to remember. But remember, log base c of ab equals log of ca plus log cb. All right, let's go over the second one. This comes directly from the first one. It's log base c of a over b equals log base c of a minus log base c of b. All right, so this might make it a little bit harder to remember both of them now, but multiplication, you get addition, division, you get subtraction. Maybe that can help you out, because when you multiply two things together, you get a bigger thing, right? Just like if you add things. And if you divide two things, You get a smaller thing, just like subtracting things, right? So maybe that's a nice way to remember it.
Hey, Aaron, we have somebody in the chat who wants you to repeat that again.
Uh, repeat, repeat what?
Didn't clarify. Sparsh, what did you want repeated?
Sparse, what did you want me to repeat? Number two, the second property. Okay. So log base C of A divided by B equals log base C of A minus log base C of B. It's right here. And it is pretty hard to remember. So I'd recommend writing these down or taking a screenshot so you guys can always just have them handy. And if you'll be able to have them memorized in the future with enough practice. All right, so now I'm going to go over the third property. And this one also directly comes from the first one. And that is log base C of, in parentheses, a to the n. So recall, if we have parentheses, we would evaluate the thing in parentheses first. So log base C of parentheses a to the n. And this is my favorite one. And that's because this becomes n times log base C of A. So basically, you can move the exponent out and it comes to the front. Isn't that kind of cool? And we can see that it comes from the first one. I'll show you guys why this third property comes from the first one. So a to the n, right? So a to the n is just a times a times a times a, blah, 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 right? And if we apply this first property over and over again, we'll get log base C of A plus log base C of the rest of this, blah, 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 blah. And then you can continue pulling out A's and A's and A's and A's, right? You can keep breaking up the multiplication here into addition using the first property. So that's why it comes from the first one. You don't have to know that, but it's just kind of a nice thing to know. But these are our three tricky log properties. And I don't expect you guys to remember this right away. You guys should just be good enough at this to be able to see the reference sheet and just be able to apply it. And on the actual entrance exam, they'll only ask very basic logarithmic things. So you don't have to worry about very tricky things. They only ask like very simple one-step problems. Maybe you only have to use one property once or something, or you just have to use the definition once. So if you don't really understand it, don't worry too much about it. It's not too important. Just if anything, I would just recommend knowing this very first, the very definition of a logarithm, just in case that comes up. All right. And just like anything to the power of 0 is 1, the log base anything of 1 is 0. Why? Well, it comes directly from the exponent property that anything to the 0 is 1, right? Because if we want to solve this, it would be c to the 0 equals 1. And this is true for any c. So that's why this property is true. All right, so these are the 4 logarithmic properties. And these are far less important than the exponent properties. So if your brain is starting to overload, I'd recommend focus on the exponent properties first, because those are definitely important and definitely will appear on the test. And for the logarithmic ones, I would recommend just maybe only knowing the definition, but in the future, you can kind of understand more and more and more about it. And maybe eventually you'll have all of them memorized. All right. So now I'm going to teach you guys some useful tricks. So on the real test, they're going to have these tricky word problems. They're going to be like, what is the sum of, well, they're not going to ask like directly, right? You're going to have to compare two things and choose the bigger one using the A, B, C, D rules, right? But maybe they'll have quantity A be like the sum of all the numbers from 1 to 100. And you'll be like, what? How do I find the sum of all the numbers from 1 to 100? Am I really going to have to add numbers 100 times? Am I really going to have to do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and do all of it? Well, you don't have to because there's actually a very fast shortcut to solving this. And I see someone already typed the answer in the chat. That is correct. It's 50-50. And here is the trick. So if I have 1 plus 2 plus blah, 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 plus all the way to n, and for 1 to 100, that'd be, n would be 100. This is n times n plus 1 divided by 2. Boom, n times n plus 1 divided by 2. That's very handy, right? This very, very long addition thing. This n could be 1 million, and then it would be impossible to solve it, right? You would have to add a million numbers together if you didn't know this trick. But all of those millions and millions or hundreds or thousands or billions of additions can be done in just this. So that is a very useful thing to know. 1 plus 2 plus all the way to n is n times n plus 1 over 2. So I'm going to give you guys a practice example now. And I want you guys to solve it yourself. I want you to apply this cool trick yourself. So I'm going to say, find the sum of all the numbers, and numbers will be integers. So find the sum of all the numbers between 1 and, let's say, 1,000. So I don't want you to do this manually. I don't want you to do 1,000 additions. I want you to use this trick. So find the sum of all the numbers between 1 and 1,000. And if you get your answer, you can type it in the chat. I'm seeing a lot of 500 in the chat, and that is absolutely correct. So all we have to do is evaluate this, and this is a little bit hard to evaluate. It's pretty big, but in the end, we'll get 500,000, 500,000, 500, yes. So you guys are all correct. Well done. All right. So that's going to conclude our concepts lecture. So I hope you guys at least learned something from this, whether it be PEMDAS, exponents, logarithms, or this nice trick. I'm going to hand it over to Kevin to go over some practice problems in the UMTYMP style format, which is with the A, B, C, D, and you compare the things. So, Kevin, are you ready?
Yeah. Okay. Do you mind sharing the screen for it, or do you want me to?
Yeah, I can stop sharing and you can share it.
Okay. Give me a second real quick. Hmm. I'm having some issues with being able to open it. So, oh, I think I need it in PDF format. Okay, 1 minute.
You guys can just use this time to either join the Google Classroom if you haven't done that yet, and or just take a short break or think about any of the properties that you're still a little confused about. Just take this time as a short break.
Okay. Oh God. Okay, guys, we're gonna do some real UMTYMP style problems. So Aaron gave a bunch of great examples, but they were just about the concepts rather than the UMTYMP exam. So these are going to be in the way that the UMTYMP exam is structured with the A, B, C, D answer choices. So I guess we can begin with the first one. For the first one, we have x is greater than 0, and then we have 4x or x over 5. So type in chat what you guys think is the answer. I'll give you guys a few seconds for that. So I see a few A's in chat, and that is correct. Normally it would be D, but since it specifies that x is greater than 0, 4x is always going to be greater than x over 5. Okay, I hope you all got that. We're going to move to the second problem. So, given that -1 is less than x and x is less than 1, uh, what do you guys think is bigger, 3x minus 5 or 2x? Not a lot of answers for this one so far.
If you guys need a quick reminder, A, B, C, or D means you have the two columns in the tables, right? Column A and column B. So you put A if quantity A is bigger, B if quantity B is bigger, C if they're the same, like they're equal, and D if you cannot determine it from the information given.
I see a few different answers in chat. Some people are a little bit confused. That's okay. This question is one of the trickier ones. But for now, let's assume that the first one is bigger. That would mean that, oops. Let's assume the first one is bigger and see if everything makes sense when after we make that assumption. So we're going to start with 3x minus 5. is greater than 2x. Right, so what we're going to start with here is subtracting 2x from both sides. So in doing so, we end up with x minus 5 is greater than 0, or x is greater than 5. Is this true? This can't be true, right? Given that we have x is less than 1 over here. So clearly the first one is not bigger. Is the second one bigger though? We still need to make sure they're not equal or it's not indeterminate. So we next try assuming that 2x is bigger. We have 3x minus 5 is less than 2x. And we again subtract 2x from both sides. And this results in x minus 5 is less than 0, or x is less than 5, which means that this inequality is true for any x less than 5. We know that x is less than 5 because of this over here. So we know that 3x minus 5 has to be less than 2x. So the answer, as many of you did say, is B. If you have any questions in the middle, if you're feeling confused on any step I did, make sure to ask a question to one of the tutors in the chat, and they will be able to help you. Okay, 52. I'll give you guys a minute for that. The two choices here are x squared plus 1 and x plus 1. Okay, so I'm seeing a lot of correct answers in chat. The answer is indeed D, because you cannot determine it from the given information. So a neat trick you can do with UMTYMP test questions is if you're not sure if it's like a variable or something, you can test in values. Some common values that are really nice are usually 0, 1, -1, 1/2. And essentially for this one, we see that if we try the value 0 or 1, we get 0. Let's say x is 0 for now. Then we get 0 plus 1, which is 1, and 0 plus 1, which is also 1. So this would make them equal. But if we try the value 2, then we get 2 squared plus 1, which is 5. And on the right side, we have 2 plus 1, which is 3. And since 5 is greater than 3, there's also a case where A is greater than B. So since there are situations where it's greater and also situations where it's equal, we actually cannot determine the correct answer from the information given, and so the answer is D. I'll write the answers next to them for now, so that just in case you guys get a little behind and want to keep track. Okay, 53. I'll give you guys a little bit to work on that. I'm seeing quite a few answers in the chat, and most of them are correct. So the answer for this one is A. When you have variables in the denominator, one important thing to watch out for is whether or not it's 0, right? If it's 0, you can't divide by 0, so it'll automatically become D usually. But notice that for this one, we have that both variables are greater than 0, so we don't run into that issue. Another thing that often makes things that you don't think are D become D would be negative numbers, but we don't have to deal with those at all either, again, because both of them are positive. So we look at these two things, And the first thing we notice is that since x is not 0, x over x is equal to 1. Now what about x over y? We're given that x is less than y, which means that x over y has to be less than 1. Thus, x over x has to be greater than x over y. So the answer is indeed A here. If this condition weren't here, you would have to deal with negative situations or denominator equals 0 situations, which would actually turn the answer to D. But luckily, because of the given conditions, it is not. Okay, question 54. I'll give you guys a bit of time for that. I see a lot of correct answers in chat. The correct answer to this one is actually B. So the long wording on this might make it a bit confusing. Essentially, 70% of the students passed, right? This means that 30% of the students failed. And so from this, we know that the ratio of those who failed to those who passed is 30 over 70, which is 3/7. Now we have to compare this number to 3/5. Since they have the same numerator and 3/5 has a smaller denominator, 3/5 is greater. Also, since they're both positive, that's an important thing to keep in mind. But just because of all of those reasons, 3/5 is greater than 3/7. And so the answer is indeed B. Next question. You guys have a bit of time to work on this. Wow, you guys are pretty speedy. I think everybody got that one actually. The correct answer is actually C. The two are equal. So just a quick run through of how you would do this. The first one, obviously PEMDAS, right? You have to do parentheses first before anything else. So to resolve the first parentheses, we add 84 and 12, giving us 96, and then 91 and 15, giving us 106. So 96 times 106. Sometimes when you see big numbers like these, you shouldn't actually do the full calculation right away because there might be some way to make the problem simpler and avoid having to do massive computations that eat away at your time. But our other thing is going to be 74 plus 22, which we have to do first since it's in parentheses, and 20 plus 86, which is 106. And we'll notice that both of these things are just 96 times 106, so they're the same thing. So our answer is C. Next question. Okay, the correct answer to this one is C. So one cool fact about percentages is that you can actually switch them around. So A% of B is the same as B% of A. The reason you can do this is because what the percentage sign actually means is dividing by 100. So we see here A over 100 times B which is just AB over 100. And then the other one is B over 100 times A, which is also just AB over 100. So in this case, we know that we can switch them around and we find that they are the same. And so we know that they're the same thing. So the answer is C. If you wanted to do the actual computation, you could, and it would probably work. But again, the UMTYMP test, a major aspect is also speed. So make sure you know these helpful tricks to prevent you from running out of time on harder questions. Question 57. This one's a little bit trickier. Let me know what you guys think. One important distinction I should make, I guess it's not too visible, but there's a decimal point there. So this is actually 0. Oh, that's a bad. That's a bad. This is actually 0.6 cubed, and that's 0.6 to the 1/3 power, if that changes anything. Okay, I think we got most of our answers in. So this one looks like it was a bit trickier for everybody. The correct answer is actually B. The thing to note here is that when the thing that's inside that's being exponentiated is less than 1, for example 0.6, or between 1 and 0, cubing it or raising it to any higher power or any or whatever actually makes it smaller. Oh, just 0.6. And then also raising it to a negative power or a power less than 1 will make it, well, yeah, will make it bigger. So 0.6 to the 1/3 is greater than 0.6. And because of this, we just know that 0.6 to the 1/3 power is greater than 0.6 cubed, because one is greater than 0.6 and another one is less. So the answer here would be B. I guess I should prove the first statement. Well, not prove. I guess I should show you guys. Like, for example, if you squared 1/2, right? Like 0.5 squared, this is equal to 0.25, which is less than 0.5. I could prove it, but essentially when you square it, right, you're multiplying it by 0.5. And since you're multiplying it by a number less than 1, you are making it smaller. I guess if it were negative, you'd be making it bigger, but that doesn't apply to this question. Okay, question 58. I'll give you some time on this one. Okay, a lot of correct answers in chat. The correct answer is C. Since x is an integer, we know that 4 times x has to be an even integer. And even integers, what's special about them? They divide evenly into 2. So 4x when divided by 2 will leave no remainder. So remainder equals 0. And since the other column is just 0, we put C because the two quantities are equal. Next question. I'm gonna have to scroll soon, so I should move these up. Oh.
Kevin, I got a request to slow down.
Oh, okay. All right. My bad. A lot of good answers in chat. The answer to this one is indeed B, as many of you said. So, first of all, I should address a pretty important thing. If the two quantities involve no variables, the answer is almost never D because there's nothing uncertain. There's just one number and another number, and one is definitely bigger than the other, or they're equal. But there's no like lack of information because all of the information is there. So if there's no A, B, X, whatever, uh try not to answer D. I say try not to and almost never because I I don't think there's an exception, but I don't want to eliminate the possibility. But as far as I know, it'll never be D if there are no variables involved. So for the solution to this question, we have to compare 2 and the square root of 5. Now, a lot of you probably don't know the square root of 5 off the top of your head. But what you should know is that 2 squared equals 4. So the square root of 4 equals 2. So right now we're comparing the square root of 4 and the square root of 5. And since 5 is bigger than 4, the square root of 5 is also bigger than the square root of 4. For those of you that are curious, the square root of 5 is approximately 2.236. Okay, so the answer is B, because the square root of 5 is greater than 2, or the square root of 4. Was that too fast? I know somebody in the chat wanted it to go slower. So if you have any feedback on that, that'd be great. Question 60 is really tricky. I'll give you guys a little more time to think.
Sorry, I just want to interrupt for a little bit, but um, I did forget to mention that on the real test, you are not allowed to use a calculator. So if you are using a calculator to answer these, just I just want to give a heads up that you can't use a calculator on the actual test. So make sure that you aren't relying too much on your calculator to solve these problems.
Absolutely true. Okay, I will begin the explanation for this one. This one is really hard, but luckily there is a neat trick that makes it a lot simpler. So, uh, besides the fact that I told you the square root of 5 before, you guys probably don't know it, or the square root of 17, right? Or the square root of 22. So you might be absolutely confused on what you do with these numbers. But again, UMTYMP is about comparing values, right? They're not asking you to actually figure out what the values are. So what you can do here is notice that 17 is greater than 16, and the square root of 16 is 4. As additionally, like we did in the last question, 5 is greater than 4, and the square root of 4 is 2. So square root of 17 plus 5 plus the square root of 5 is greater than 4 plus 2, which is 6. On the other hand, the square root of 22 is less than the square root of 25, which is 5. So the square root of 22 is less than 5, and the square root of 17 plus the square root of 5 is greater than 6. Just because of this, the square root of 17 plus the square root of 5 is greater than the square root of 22, so the answer is A. One thing to keep in mind, it is not true that the square root of something plus the square root of another thing is equal to the square root of those things added. This is a pretty common mistake to make, and it's actually really understandable. But yeah, be careful of that. In a similar way, a squared plus b squared is not equal to a plus b squared. These are probably two of the most common mistakes that people usually make with these types of problems. So just be careful you're not doing that. Sorry, I wrote a lot. It's going to take a bit to clean up. You guys can work on question 61 in the meantime, though. Next one is pretty tricky as well, so I'll give you guys a bit more time. I can scroll down if necessary. Just let me grab all of these. Actually, I'll just keep a running list here so that it doesn't get too messy. This now should be good to get rid of all of this. Cool. Okay. Yeah, I can scroll down now. Okay, I hope that was enough time for everybody. If this one's really hard, so don't feel bad about not knowing how to do it. But the important thing here is recognizing that A over B times B over C. When we do this, we get AB over CB. Since there's a B multiplied on the top and bottom, we can eliminate that to just get A over C. So the product of these two numbers is A over C. And so we can just multiply them to figure out what this quantity is. Also, we know that B is not 0, which is why we can safely cross it out, because it's in the denominator of the first quantity. So multiplying the two, we get 4 over 5 times 9 over 7, which is 4 times 9 over 5 times 7, which is 36 over 35. And this is greater than 1, which is 35 over 35. So we go with answer choice A. Cool. You guys can start working on 62. I'm going to clean out the board and add it to the list. Good placement. a lot of mixed answers here, but I do see the correct one the most. So the correct answer is actually B here. Thank you, Sparsh, for your explanation. It is because the second one doesn't have the percent sign. So we know that 3/4 is equal to 0.75, right? So it'd be easy to say C and get it over with if we don't see the percent sign. But if you remember what I said about the percent sign in the earlier question, it actually means dividing by 100. So you have 0.75 divided by 100 compared to 0.75. This is 0.0075, and it is far less than 0.75. So the answer is B. You guys have no questions. Go ahead and move on to question 63. Seems like the chat is unanimous. So the correct answer for this one is indeed B, as all of you said. If we do we know what prime numbers are? Prime numbers are numbers that can only be divided by one, that only have factors of one in themselves. So the first few are 2, 3, 5, 7, 11. These are all the ones less than 12, so they're the only relevant ones for this question. And we see that only 5 and 7 can add to 12. So 5 times 7 equals 35, which is less than 38, which means that the second answer is large, the second quantity is larger, and so it is correct. Also, even if you remove the prime number condition, the answer is still going to be B because the greatest that xy could be would be 36. So just an interesting fact. Go ahead and get started on question 64. That one is pretty tricky. Some of you are really quick. So I see again, the chat seems to have decided on a single answer, and it is correct. It is A. The reasoning behind this is the first quantity is just A plus B squared, and the second is B minus A squared. So since we know that A is positive, we have, oh, wait, it's important to note both things, I guess. But first of all, since A is positive, B minus A is less than B plus A. But then we also have to consider what if B minus A is more negative than A plus B is positive? Because that would make the square greater, right? For example, -7 is less than 5, but 49 is greater than 25. Oh my God. So, but we look at the second inequality and we see that B minus A is positive, and A plus B is also positive. So since A plus B is greater, A plus B squared is also greater than B minus A squared. However, if it doesn't specify this, the answer would be D because of like a situation like this that I mentioned above. So always keep a lookout for that. And last question. Last one is similar to the ones mentioned before, or some of the ones mentioned before, but go ahead and give it a try. Okay, great. A lot of correct answers. The right answer for this one is B. So this one might be a little bit more confusing than the first ones because it's not exactly the same. You might try the inequality thing, right? Square root of 10 is less than square root of 16, and square root of 10 is less than, well, I guess it's the same thing, 16. So their sum is going to be less than 8. However, this doesn't quite work because even if you know it's less than 8, that doesn't really tell you about how it compares to 7. It could still be greater than or less than. So what do we do here? I guess you could do what Sparsh said and say it's about 3, so it should be less than 7. But we obviously want a more sure way so that we can guarantee that we're getting these points on the UMTYMP exam because the cutoff for making it in is very high and we don't want to drop any due to careless mistakes. So what we do is when we add them, we see that root 10 plus root 10 equals 2 root 10. And then a way you can do that, and then how you introduce the 2 into the thing is you change it into a root 4, and now you have root 4 times root 10. And like Aaron mentioned, the multiplication is distributive, so you can put the whole multiplication inside the square root, and it becomes square root of 40. By contrast, we know that that 7 squared is 49, so the square root of 49 equals 7. So on one side we have the square root of 40, and on the other side we have the square root of 49. And since 49 is greater than 40, the square root of 49 is also greater. So we get the answer B. And that is it for this week's example problems. You guys will be taking the practice exam soon. Feel free to take a screenshot of this answer key. We will post these problems later so that you can review.
Bigger than 8, so the answer is going to be A. A. Okay. And Eric, you want to go over the even problems? Actually, I'll go over the even. You can go over the odd, right?
Make sure you guys use the PDF as the questions on the PDF are different.
Oh, okay. Right. And so we'll go on to number 2. Average speed needed to go 350 in 5 and 780 in 12. So this is a pretty standard one. You want to find the average speed, so you just divide 350 by 5, which is 70. And then you could do 780 divided by 12, which is, I believe, 65. And so 70 is going to be bigger than 65 all the time. There is no cases where it isn't, so it's going to be A. And Eric, you can do number 3.
For number 3, we have on the first column we have x. On the right column we have 2x. See, x in this case isn't given a parameter, so x can be technically anything. If x is 1, then column B will obviously be greater than column 1. However, if um, x is equal to 0, then both will be equal to 0, so they're the same. So in this case, the answer option will be B, which in case there will be more information will be needed to be given.
Okay, and moving on to 4. And as you can see here, we're given that x is going to be greater than 1 all the time. So that will allow us to solve this. So 2x squared versus 2x cubed. And in this case, because x is not negative, they're both going to be positive at all times. And since x can't be 0, they'll never be equal. And so we can just simply take out the 2 from both sides to get x squared versus x cubed. And since x is a positive number over 1, x cubed is always going to be bigger than x squared, which means the answer is going to be B.
All right, for number 5. All right, for number 5, originally it was supposed to be 32 to the 20th power on the right side and 2 to the 100th, and we're supposed to make you use exponential rules. However, it appears we made a mistake and we actually did 2 to the 320th, 3 to the 320th power, 220th power. So yeah, from that approach, it's clear that it was B, but we'll change anybody's score who got that right, but we marked that as wrong.
All right, now for number 6, the number of hours in a year versus the number of seconds in a day. So at first glance, you might think that there are more hours in a year than there are seconds in a day. But if you think about this one, it's going to be 365 times 24. And then I'm not going to tell you the exact number for that because you actually don't need that. So you have 365 times 24. And over here, you'd have 60 seconds in a day, 60 seconds in a day. So a minute has 60 seconds, and there are 60 minutes in a day, in an hour, and then 24 hours in a day. So you have 60 times 24, which is 3,600 times 24, which no matter what, since 3,600 is bigger than 365, this is always going to be bigger. So it's B.
All right, for number 7 from, it looks like here, it's kind of hard to see, but that's a division symbol. We have x squared over x on the left side. We also have x cubed over x squared on the right side. And the correct answer for this is C, that both are even, because x squared divided by x, but that can be simplified down to x, and x cubed divided by x squared will also be equal to x. And since x is always positive, then we have it will always be equal to each other.
Now we have this problem right here. This is a pretty simple problem because 368 is constant on both sides. You just have to look at the other number and see which is bigger. And as you can see, 9 is going to be bigger than 8.7, so the answer is going to be B. All right, Eric, number 9.
All right, number 9. Give me one second. Number 9. Number 9, we marked it as C. Both are even. Let's see. If we use the square root rules that were taught today, we could find out that they're both even. It's C, so none are greater than another.
Yep. Now we move on to this question in which Megan and Sharon both eat cookies. Let's look at the amount of cookies Amy ate versus the amount Sharon ate. So as you can see here, Amy took 30% of the total cookies and then ate 1/3 of her share. So that's going to be 10% of the total cookies. Sharon took 40% and then ate 1/4 of that share. So as you can see, 40 times 1/4 is going to be 10%. So from here, we can see that this is going to be C. So since they're both equal.
For number 11, it's kind of straightforward. On one side, we have 5.19, and on the other side, we have 5.4. And since 4 is greater than 1 for the 10th decimal place, then 5.4 is greater than 5.19. So the answer is B.
And then moving on to here, where we have x and then x plus 2. So in this case, you might at first glance think that B is going to be bigger, but keep in mind that that's only for when x is greater than 0. If x is less than 0, in this case, this would be negative, like let's use -2 as an example. This would be -2, and this would be 0. So then B is going to be bigger. So the answer would be B. But then if x is positive, this could be 1, and this would be 3. So B would be bigger. Yeah. Wait 1 second. So no, in this case, B is always bigger. My bad. Sorry. Moving on to 13.
But for 12, B is always bigger.
Yeah, 12B is always bigger, yeah. Because even if it was negative, this would always be bigger. I was getting confused with multiplication for a second.
All right.
Excuse me, sorry
Answer
to
is D.
interrupt, but
Yeah.
on the test, it said that the correct answer was D.
Yeah, don't worry. We'll go
12?
back and fix all those.
Wait, Kevin, I did this problem. Is 12 is B, right?
What was B?
Okay. I might
12
have,
is B. It's okay. We'll go back and
yeah, we'll
individually
go
change
through and
them.
fix that.
All right, 13. 13 is kind of, well, maybe not obvious. 13, we have 0.75%, and on the other side, we have 0.0075. Now, if you're wanting to convert a percent to a decimal, you have to divide the percentage by 100. So in this case, you would just add 2 zeros after the decimal place as a trailing zeros, and then you'll have 0.0075 is equal to 0.75%. So the correct answer is C, since they're both the same.
All right, moving on to 14. 2 to the 100 versus 4 to the 51st. So over here, at first glance, you might think this is bigger, but then the way to do this one would be to take 4, which we know is 2 squared. And as Aaron said earlier, and we covered this rule earlier, so we can do 2 times 51 to get 2 to the 102, which we know 2 to the 100, since 102 is bigger than 100, this is always going to be bigger. So this answer would be B.
All right, and I was looking through 15. That's x squared, is it not?
Yeah, I believe it's X. Yeah, that's X squared.
Yeah. I mean, since x isn't defined, technically, if x is equal to 0, both sides would be equal to 1. However, for any number greater than 1, for any x greater than 1, we'll have, it'll be right on the whiteboard, please. For any x greater than 1, we should have a column is greater than 1, so it should be undefined, right?
It should be D, but I think we might have put the answer as A in the.
All right, I'll write that down. We'll go back and change it later. Could we have a question? Could we have a second try on the test? You can't really have a, okay, whoever is putting question check marks spaced out.
But keep in mind, this is only a half-length practice test, so don't worry about too much while you get on here. As we go through, we'll have longer tests. Okay, moving on to 16. So this might look big, but this is really just since the first numbers are the same, we can just take them out and compare the decimal place. And as you can see, this has a 1 in the 10th position, while this has a 0. So this will always be bigger than this, making it B.
Question number 17. It looks a bit weird on this thing, but it's just 1,000 times 1 over, what is
1
that?
over 10.
1 over 10 times, or basically an orange number, but times 0. The answer to number 15 is, we think it's D, because if e to the 0th power for both sides will be equal to 1. But if x is greater than 1, then
Yeah,
side A will be bigger.
I think
So
what
we'll
happened
mark,
there was I think we forgot to put in the condition that x is greater than 1, 0.
yes. So for that one, we will have to mark it as B for the test. But moving back on to 17, right, by sparse. Well, going back to 17, there's a multiplied by 0 on the final part for number A. So since it's multiplied, then everything that's on column A will be equal to 0. And since 0 is smaller than 0.0001, then side B will be bigger. So 17 will be B.
Okay. Moving on to number 18. So this one will need you'll need to know some arithmetic computation abilities and finding the pattern. So what we can do here is that sum of all even numbers is going to be 2, 4, 6, 8, etc., until 100. And what you can see here is that it's always going to be, we can call each position like N1, N2, etc. And you can see that N2 is equal to 2N1. So the common pattern here is going to be N, let's call it A. We'll call it A of N plus 1 is going to be equal to 2AN. And as you go up to 100, this is going to equal a very large number. And if you keep doing it, you get, as you could also do the pattern that Aaron stated, in which you do 100 plus 2, 98 plus 4. So we get 102 times the number of digits there are, which would be 50, and do that over 2. And then for the same thing goes for the odd numbers, only we'd have 1, 3, 5, etc. like that. And then we'd have 99 on the end. So we could do 99 plus 1 is 100. And then multiply that by 50 as well. And it's over 2. And so here you can see that we have the same equation essentially, only we have 102 here and 100 over here, which means that since this is going to be greater all the time, so the sum of all the even numbers will be greater.
All right, for number 19, we have sum of all factors of 20 and sum of all whole number divisors of 27, which I mean that's also sort of like you can also factor that out. So for 20, we can factor that out to 2 and 10. And that can also be factored out into 1 and 20 and also 4 and 5. So you have 1, 2, 4, 5, 10, and 20 are all factors of 20. And if we go on to column B, we have the sum of all whole number divisors of 27. Now, what can divide 27 and have no remainder? We have 1, we have 3, we have 9, and we also have 27. And now this is just simple math. If you add together the second column whole divisors of 27, 9, 3, and 1, you get 40. And the sum of all factors would be 1, 2, 4, 5, 10, 20. And add those together, you'll get 42. So side A is bigger. So the answer should be A for number 19.
Okay, thank you. And now for 20, we have 5% of 130 and 130% of 5. And so a cool trick about percentages actually is that you can switch the two numbers around. So you have 5% of 130, so you could do 130% of 5, and that would be the same thing as this. And so here we can see that is exactly what has been done. So they're actually both equal. So we can do C. So that's just a cool trick you can remember. And for 21, I think, you know what that means, Eric?
21. Let me check the answer key we have. 21 is D. 21 is D because there's no condition for X and Y. Y can despite 99 times 99 to the 99th power being a really large number. If X can be anything and Y can be anything, then Y can always be greater than X and X can always be greater than Y. So since this is true, we don't know. We don't know which is greater than the other if they're equal. So we'll put D as more information will be needed. More information will be needed. Right.
Okay. And now for 22, we're given that the absolute value of X is going to be less than 4. And since it's an absolute value in both these cases, X is never going to be negative. So that means we can see that they're both going to be positive numbers that we can compare to each other. And so let's look at when X is less than 4. Let's plug in like 2. So then we get 2 times 2 plus 5, which is going to be 9. And 3 times 2 plus 1 is going to be 7. So we can see A is going to be bigger than B. And this is going to actually hold true for all of the numbers less than absolute value less than 4. Because if you go past 4, let's say 5, you'd get 2 times 5 plus 5 is going to be 15. 3 times 5 is going to be 15 plus 1, so 16. So you can actually see that B is going to be bigger. And this is just a simple, this is simple because 4 is actually where these two like graphs intersect. And so below that intersection point, this is always going to be bigger. So this is going to be A.
All right, for number 23, right, we have, let's see, 1 plus 2 plus assumed 3, 4, 5, all the way to 9 plus 10, and on this side we have 56. Now we did learn the series rule for today, and you can use that definitely, or you can, since this is a technically a short series, you can also just add them together individually by writing it down, but it will be quicker if you use our method. So we would, since you can count how many numbers there are from 1 through 10. There's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In total, when you add them all together, there's a total of n equals 11. So there's a total of 11 numbers in there. So if you do our equation, 11 times 11 minus 1, which is equal to 10 divided by 2, you get 55. And since 55 is less than 6, and column B is greater, so the answer is B.
Yep. And 24, the last one I'm going to be covering, is, as you can see here, it's actually just a simple exponential rule, which Aaron did cover in the lecture. Same goes here. So what do we do here? We multiply the two exponents, right? So we have 2 times 4 and 4 times 2. And by the commutative rule of multiplication, they're both equal to 8. So this is just x to the 8th and x to the 8th, which is going to be equal to each other no matter what. So this is going to be C.
Right, for number 25, we're given a variable A. Okay, and there's no parameters. A can be anything. There's no condition, so A can literally be negative infinity to infinity and beyond. But we don't know. We don't need to know that. All we need to know is that these two, the answer is D, because these two will need more information to be given. Since column 1 and column 2, either one can be greater than each other in certain scenarios, but also they can be equal to each other when a is equal to 1. Because when a is equal to 1 squared is also 1, and 1 cubed is also 1. So then logarithm of 1 is always e is 0, and they're both equal to each other. So the correct
Yeah,
answer is D for
so
25.
also don't get confused that it might be C because you might use the property where you take the exponent out in front, right? So the left would be 6 log A and the right would be 8 log A. And then you might think that it is B, but it's not. As Eric said, if you plug in 1, they both become 0. But if you don't plug in 1, like if you plug in 10, then it would be B. But since it can be C and B in different cases, it has to be D.
All right, so that's the mock test, and I think we just